So today we're diving into backend security. But look, this isn't going to be just a long list of tools to use. We're going to talk about building a mindset. Let's call it productive paranoia. It's all about learning to think like an attacker. Let's just cut right to the chase. This quote, it says everything. Security breaches aren't some kind of dark magic. Nope. Almost every single one happens because a developer, probably under a tight deadline, made one tiny simple assumption that the stuff coming from the user would be, well, clean. This right here, this is the one question that attackers ask over and over and over again. They're not looking for some secret hidden backdoor. They're looking for the corners you cut to ship a feature on time. If we can start asking this about our own code, we are already halfway to beating them. And here's the thing you have to understand. Attackers do not care what fancy framework you're using or who your cloud provider is. They are laser focused on one thing, hunting for the assumptions you made under pressure. They will poke and prod at every single boundary, they'll test every input field, and they will exploit the assumptions you didn't even know you were making. Think of your application like it's a multilingual translator. It's constantly switching between contexts, right? It's speaking SQL to the database, then it's speaking shell to the operating system, then it's speaking HTML to the browser. Vulnerabilities pop up when a message in one of those languages gets misinterpreted as a command in another. And that leads us right into the first huge assumption developers make, that user input is just harmless data. The moment we fail to draw a hard line between the data a user gives us and the code that actually runs our system, we swing the door wide open for a massive class of problems called injection attacks. So what is an injection attack really? Well, at its heart, it happens when that boundary between data and code gets all blurry. An attacker sends in this carefully crafted piece of data, and your application mistakenly runs it as a command. And the results, they can be catastrophic. Okay, let's make this super real. Picture a simple login form. All the developer wants is an email address, but the attacker, they provide this weird-looking string. To you and me, it's just gibberish, but to an SQL database, that is a perfectly logical and absolutely devastating command. And here's the payoff. Instead of the database finding one user, it gets tricked. That little or 1 equals 1 piece is always true, so the database says sure thing and returns every single user in the table. Just like that, the attacker has bypassed your login and is walking away with your entire user list. So how do we stop this? The answer is simple, and it's non-negotiable. You have to use parameterized queries. It's a technique where you send the query's structure and the user's data to the database in 2 completely separate steps. This tells the database driver, hey, this stuff from the user, never execute it. It's just a string. This one simple practice shuts down this whole category of attack completely. Okay, on to the next big assumption, that a user is who they say they are. This gets us into authentication, and more specifically, the absolutely critical job of storing passwords. Let me tell you, getting this wrong is probably the fastest way to lose your user's trust, forever. Let's do a quick walk through the history of how we learned to get this right. Okay, storing passwords in plain text? Never, ever, ever do this. Hashing is a step up, but pre-computed rainbow tables can crack common passwords in an instant. So we started adding a unique salt to each password before hashing. That defeats the rainbow tables. But today, the standard is slow hashing. These algorithms are designed to be painfully slow and expensive to run, making it take centuries for an attacker to crack them, even if they have your whole database. But wait, security doesn't just stop once the user is logged in. I mean, think about it. Just because you have a key to get into the building, that doesn't mean you should have access to the CEO's office, right? This is the huge difference between authentication and authorization. Let's just break it down nice and simple. Authentication, or authn, is all about verifying who you are. It's answering the question, who are you? Authorization, or authz, comes next. It answers the question, okay, I know who you are, now what are you actually allowed to do? And the most common mistake here by far is something called Broken Object Level Authorization, or BOLA for short. This is what happens when your application confirms that a user is logged in, but then it fails to check if they actually own the specific piece of data they're trying to look at. It's really just a failure to check ownership. So here's how this plays out in the real world. An attacker logs in with their own account. They see in the URL something like /invoices/102. So they ask themselves, I wonder what happens if I just change that 2 to a 1. If your backend doesn't explicitly check that Invoice 101 belongs to this specific user, you just leaked another customer's private financial data. All right, let's tie all of this together. We've seen how attackers are always looking to exploit our assumptions. So the antidote is for us to develop our own set of defensive principles. It's about that productive paranoia we talked about, applying it to every single line of code we write. So here are the key takeaways, the new rules to live by. Number 1, trust no input, ever. Treat it all as hostile. 2, always keep your code and your data separate. 3, deny everything by default. Permission should be given, not assumed. And 4, on every single request, check for ownership, not just that the user is logged in. And at the end of the day, that's what this all comes down to. Writing secure code isn't about memorizing some giant list of vulnerabilities. It's a mindset. It's about a continuous process of challenging your own assumptions. Because the exact moment you think to yourself, a user would never do that, well, that's the exact moment an attacker is about to prove you wrong.